So equations with decimals and just like regular equations, nothing really changes. It's just now we're working with decimals. So we still have the principles of equality. Whatever you do to one side of the equal sign in operation, you need to do the same thing to the other side of the equal sign so that we don't change the balance of equality. Um, so all the operations that we've been doing with fractions, I'm sorry, decimals, now we're going to apply them with these principles of equality. Again, it's just addition, subtraction, multiplication, division of decimals. Now I'm just going to reiterate this as well. Remember, with multiplication and division, that means we're usually trying to get 1, right? That's the coefficient. It's the number being multiplied by the letter. We want that to be 1. And we use addition or subtraction to get 0. Or we're trying to cancel out a value so that it's not there anymore. It becomes a phantom 0. So a problem like this one, and again, I'm not doing this by hand anymore just because we've gone over that in the section. We want you to know how to do it and check with the calculator. I'm going to be doing these with the calculator and just hopefully I don't make the same mistake where it's multiplication and then I put division or that I type it in the number incorrectly. Okay, and we need to be careful when we use the calculator still. The calculators don't make mistakes, but operators do. So, and you guys have seen me do that, which is good. I want you guys to be able to make mistakes and be okay with it, all right? But we need to be able to check and make sure that it works out properly. We'll be checking our actual work with the calculator, and we'll do it the same way we were doing or checking our equations from Module 2. So first thing I see on this one is I got an m, but it's being added to this 12.2. I don't want numbers, I don't want letters adding numbers together. Okay, so I'm going to zero out the 12.2 by subtracting 12.2 from both sides. So minus 12.2. So that does zero out. 12.2 minus 12.2 is actually 0. I'll drop the m. So this equals negative 3.8 minus 12.2. And that is negative 16. If you want to put negative 16.0, that's fine. But again, I'm a lazy math person, so I write negative 16. Now, the next thing I would do, just to check, right? So I'm looking at the checking portion of this. Is I said m is negative 16, so I'm going to write, or I'm going to check the equation, but instead of m, I'm going to write in negative 16. So it's negative 16 plus 12.2. Does this equal, and that's why I got the question mark there, negative 3.8. Let's check with the calculator. Negative 16 plus 12.2. And if we did it right, it should come out as negative 3.8. It does. So I know that negative 3.8 is actually equal to negative 3.8. That is true. And now I know with confidence that m does actually equal negative 16, or that m equals negative 16 is a solution to this equation. All right, so with that, we used subtraction on that last one. See if you guys can do this one. 30 seconds, solve for x, okay? 30 seconds, go. All right, hopefully that was enough time. If you guys are still finishing, do finish, and then check your work with what we got here. So we got negative 3.9 times x. Now remember, I don't want anything added or subtracted to x, which there is none. So I'm not worried about that. What I don't want, though, as a coefficient of x is negative 3.9. I don't want that there. What I want is 1x. Okay, I'm okay with the 1 because we could make it a phantom 1, which is what it was in that last problem. So whether you show the 1 there or not, we are trying to get a 1 as a coefficient. So how do I make a negative 3.91? Well, to do that, I need to divide both sides by negative 3.9. Because anything divided by itself is 1. Right? This is a 1. That's crossing them out, but it's crossing them out with a 1. Okay, that becomes our 1 right there. So I go to the calculator, I type in negative 12.87 divided by negative 3.9 to get 3.3. All right, that's pretty good. 3.3. So this is what x should be. Well, let's just double check and check this in the calculator. Again, I need negative 3.9 times 3.3 to equal negative 12.87. So I go into my calculator, negative 3.9 times the x, which we now say is 3.3, and we get negative 12.87, which is what we had originally in this problem right here. Okay? So that checks off. Again, it's not required that you show your work on that. If you wanted to, that's fine. Right here, I'm just saying x equals 3.3. Again, if you want to show the 1 there, that's fine. That's a great point. So on this one, let's say, because this is a common error that we find in this class, and even in 980 and 1010, a lot of students make the same mistake at the beginning, right? With enough practice, we'll take care of it. But we say, well, we understand we don't like that negative 3.9 there, and so we say, well, we're gonna take and add 3.9 to both sides, right? So add 3.9 to both sides, and then this would give us x equals at negative, what was it, 8.8 or something like that? 8.97. Thank you, 97. Now, the thing with this is, if this was addition right here, let's say that I'm not even considering the x. If I said, well, this is addition, it would end up being 0 right there, actually. Now, we don't want a 0x either, because that's saying we don't have any x. And there's no x that's equal to negative 8.97. Let me rephrase that. There's nothing, because 0 is nothing, right? Nothing equals negative 8.97. Now, you guys will go into this more detail in 980, but this can't happen. This 0x thing. Now, again, that's just noticing that negative 3.9 plus 3.9 is 0. The other thing we want you guys to notice is from this that negative 3.9x is not a like term with positive 3.9, which means that we are not able to combine them with addition or subtraction. So that goes back to, I think it was 2.2. This term has an x. This one does not. So I'm actually not able to add or subtract right there. That's where it becomes important, is knowing that there is a difference between addition and subtraction and multiplication and division. So in this case, the negative 3.9 is the coefficient of x right here, but we don't want anything but the coefficient of x to be 1. And then it becomes a question, well, how do we make it a 1? Well, when we're making 1 in an equation, we always use division. And we're always just dividing it by itself like we did right there. Anything divided by itself is 1. And then whatever you do to one side, you got to do to the other side as well. So yeah, just understanding the different operations and even what their purposes are, right? And that's why at the beginning there with the properties of equality, knowing when to use addition and subtraction or multiplication or division is crucial. And hopefully by just looking at the evaluation on this, right? Like, well, right here we see they're not even like terms to allow us to use addition. So we got to use multiplication or division. And up here, it was multiplication. So how do we get a 1 out of that? Just divide it by itself. All right, so a problem like this one, I don't want x to be divided by anything, like this 5.3. Garbage, man. We don't want that there. So I need to get rid of it. Well, it's divided by 5.3, so I'm just going to use an inverse operation of multiplication, right? Of, well, itself. 5 point. All right, so this 5.3, that's pretty much the same thing we're doing on this one. Is instead of using, I guess, even the principles of equality, is like, well, I'm using the opposite. It is the principles of equality. I'm just using the opposite operation or the inverse operation for this. So whereas right here it's divide 5.3, that's why we're going to multiply it by 5.3. But again, you do it on both sides of the equal sign. Now that, just to clarify, that's 5.3 divided by 5.3, which is why it's 1. And then we get x equals, whatever that is, negative 4.2. I'm just putting the calculator there, times rather, not divide, times 5.3, which is negative 22.26. And then, just to check on this, we'll divide that by 5.3 to make sure it checks off. And it does, so we're good. Yeah, on this one, we got that minus 0.28 with the r. Now, the first thing we should always be looking to do, well, I guess if it were bigger, like this is just a two-stepper, so that's not too bad. But generally, we look to distribute if necessary. This one doesn't need it. We can combine terms if necessary, combine like terms. But there are no like terms on either side of the equal sign to combine. So I'm just looking at these as two expressions, which means that I'm next trying to isolate, in this case, the r's. So I got negative 0.32r, but it's not isolated. It's not by itself on its own side of the equal sign, which means that that minus or negative 0.28, I can't have that there. I need to get rid of it. Now, to get rid of a negative 0.28, I need to zero it out. So I would add 0.28 to both sides. 0.28. Then I drop this negative 0.32r. Now that isolated it because this has become a 0. And we'll do I'll just put that in the calculator because I'm worried I'm going to do it wrong in my head. So negative 0.0368 plus 0.28. That gives us, that's positive now, positive 0.2432. So, excuse me. So this is now isolated the variable so that it's on its own side of the equal sign by itself. It's not being added or subtracted in anything. Now it's only a partial r. It's a negative 0.32 r's. But at least I don't have addition or subtraction with it, which is what we want. Now we've maintained the principles of equality because we added 0.28 to both sides. But now we run into the same type of problem as we had those two problems ago, where it's like, well, I don't want negative 0.32r. What I would like is just 1r. Because once I know what 1r is, then that's what nr is. Well, how do I make a negative 0.32 a 1? Well, I'd have to divide it by itself. Now again, if I had said, well, I'm going to add 0.32, then it becomes an unlike term. And that's why even this 0.28, it's paired with the negative 0.28 because they are like terms. And this one over here is paired with the negative 0.0368 because it is a like term. So if there were other r's over here, I couldn't pair this with the r's because they're not like each other. So we go to this 0.2432 and divide it also by negative 0.32 as well. So I'll take that to my calculator, divide it by negative 0.32, which gives me negative 0.76. And then, of course, my last step here is just to double check. So negative 0.32 times r, which we just found, is negative 0.76 minus 0.28. And what do we get? Negative 0.0 368. So that checks off, and we see that this answer is correct. All right, here's a good looking one. This one takes us back, but hopefully you guys still feel comfortable doing it. Take a minute and see if you can do this one, and then we'll go over. All right, 1 minute, go. So to start this one off, this one we do need distribution. So let's start with that. So I got this 0.2. We're only distributing it into this set of parentheses. So it's 0.2 times c. That's just 0.2 c. Now this next one is 0.2 times, that's a 0.2 times 3.5. So again, I would just put this in the calculator. 0.2 times 3.5, which gives me 0.7. Now that's a positive 0.7, so I keep it as plus 0.7. Now this next set of distribution, that's actually distributing. It's not 0.04, it's negative. Because remember, terms take the operation immediately to its left as its sign. So it's a negative 0.4 times c first, which would be negative 0.04c, like this. And then we also have negative 0.04 times negative 12. Again, the 12 is taking that minus as its sign, being negative. So we'll type that into the calculator. Negative 0.04 times negative 12 should be positive 0.48. So since it's positive, we're going to show it as addition, 0.48, and that takes care of all of the distribution. So this equals negative 8.2. Next, we'll simplify this by combining any like terms that we see on either side of the equal sign. So let's start with the left side, and I see I've got these c's. Now that's 0.2c minus 0.04c, which should come out as 0.16c. And then we got just the constants, 0.7 plus 0.48. So that comes out as positive 1.18. And again, this equals negative 8.2. There's no... the right side of the equal sign is just a single value, so I'm not looking to combine terms with it. Now I have a simplified equation, just a two-stepper, similar to we did the problem, last problem I think we did, right? And that means that I want to isolate the c's now. So I don't want that plus 1.18, which means I need to subtract it from both sides of the equal sign to zero that out. And it does. Positive 1.18 minus 1.18 does zero that out. We're going to drop this 0.16c, which equals negative 8.2 minus 1.18 would be negative 9.38. But I don't want 0.16c, I want just 1c. So how do I make a 0.16 a 1? Just divide it by itself. But if I do it to one side, I need to do it to the other side as well. So that becomes a 1c. And we'll do negative 9.38 in the calculator divided by 0.16. 0.16. And that gives me negative 58.625. So I have this value of c that I think is negative 58.625. But I'm going to go into the calculator and check. Now, instead of typing in negative 58.625 a lot, I'm going to show you guys a trick on the calculator, which is going to allow us to just, it's not going to be a c, it's going to be an x instead. And I can store this value into the calculator so I can check the work without having to type this number in all the time. Here's how. So I can see I've got negative 58.625 on the calculator. At the bottom left, and I'm trying to think on the Casio's, I don't remember how to do it on the Casios, but I think there is a way. In any case, on the TI-30 here, I'm going to say store, and then right above that, stores to the left of 1. Right above the storage button is the X button. I'm going to say, look, I'm going to store this in for X. When I push enter, now the calculator knows when I type in X, I really mean negative 58.625. So now I go back to the original equation, which is 0.2 parentheses. So I go to my X button instead of C, X, 0.2 parentheses. Now again, that's C, but I have it stored in as X, so I'm just going to type the X button. And then plus 3.5. I'm going to close the parentheses. Then it shows minus 0.04. Then open a parentheses. Again, we got the C, but right now I have it stored in the calculator as X. So I push X minus 12. There's my 12. Close parentheses. Now that's the full left side of the equal sign. When I push equals or enter on the calculator, it should come out as negative 8.2 if I've done the math correctly. So I push enter, it shows me negative 8.2. And now, and again, that's without having to type in negative 58.625 as C both times. Then, and you may think to yourself, well, I only had to type it in twice. It wasn't really that much work. That's true. Again, this shortcut, hopefully it saves you time in the future, especially as you get more experience with these types of problems. And just so you guys understand, this is a short problem. Like right now, it may seem long, but by the time you guys get into a 10-10 class, when you see a problem this size, you're going to be like, wow, that's a short problem. I'm not saying that to make you guys feel bad. Like, it feels like it's huge now, but in the future, it's going to be small. Yeah, you'll work up to that point, okay? It's not like they're going to take you from this to suddenly a giant problem, all right? All right, find the perimeter and area of a rectangle of cardboard, whatever. Doesn't matter what it is. Measuring 5.6 centimeters by 9.8 centimeters. All right, we can do that. In fact, I'll draw the picture of it just because, I don't know, pictures are pretty. So 5.6 centimeters and 9.8 centimeters. All right, let's start with the perimeter, right? Now with the perimeter, I need all 4 side lengths. So this would be 9.8 centimeters as well, and 5.6 centimeters opposite as well. So opposite side lengths are the same with rectangles, which makes them extraordinarily convenient. Now if I want perimeter, I need to add all 4 side lengths together. So that's 5.6, 9.8, 5.6, and also 9.8. And yeah, like I said, we're just adding these together. So I'm just going to put this directly into my calculator. 5.6 plus 9.8 plus 5.6 plus 9.8. Like it kind of glitched on me there. 30.8. So my perimeter for this problem is 30.8. Now, the perimeter is not 30.8, you guys. And no, this is not a trick question. I'm not even trying to trick you guys. I just want you guys to remember that since this is a word problem, just need to label it, that's all. So I got the perimeter right there. It's pretty good. But we also need the area. Well, area is length times width, so you just take 5.6 times 9.8. And again, I'll put that in the calculator. 5.6 times 9.8, which equals, on the calculator, 54.88. But again, don't forget your label, and this one is in square centimeters. So there's our 2 answers. All right, Pam needs to rent a car while on vacation. The rental company charges $19.95 plus 15 cents for each mile driven. If Paige only has $40 to spend on the car rental, what is the maximum number of miles she can drive? we'll write an equation to solve this. So, and I believe on the homework this wants two parts. You have to write the equation and then also solve it. All right. So let's formulate the equation first for this. So we're comparing this with how much money Paige has, right? So we have, we'll say the cost, right? We have the cost, and then we have Pam's money. What's Pam? Paige. I said Paige right there. There's Pam. We'll say Pam, okay? Pam's money. Well, since it's asking for the maximum number of miles, and the miles is related to the cost, excuse me, that means that, I mean, they could be equal, but it would be really nice if Pam had enough. So Pam either needs to have more than the cost or equal to the cost. Now, this becomes a inequality, which we're not really concerned about right now. So I'm just going to make this an equation, all right? We'll just see where they're equal for now. Now, the cost is divided up into two parts. You have kind of the base charge, right? We'll just say it's a fee because base charge is a lot of writing. But in addition to the fee, you also have the mileage. So Pam is also charged for the miles. And again, we want to know where this is equal to however much money Pam has. Pam's money. However you want to write it. Now, we know these values, though, okay? Whoops. We know these values. We got the fee, which is shown here at the top there. It's $19.95. The mileage, though, is based on the miles driven. So on this one, where it says it's 15 cents for each mile driven, we need to take 15 cents and multiply it by the number of miles. Well, we can use M, but I'm going to define it, all right? So I'm going to say up here, M equals number of miles driven. Miles driven. All right, so I've defined my variable. My handwriting may not be great, but it's still defined. And that becomes this expression for the cost of the mileage, 15 cents per mile. So multiply that by the number of miles, and I will know how much the mileage alone costed me. Add those two together, and we get the cost. Well, this equals Pam's money, which up here is shown as 40 bucks. So Pam, you got 40 bucks. This becomes the equation, and this will tell me how many miles Pam can drive to equal $40. Well, we got an equation, and we need to solve it. So let's go ahead and solve this one. What I'm going to do here is I want to get those m's isolated, so let's subtract the 1995 from both sides. Now, we did use an equation, or we're using an equation to solve this. I would say that it's not necessarily a requirement if it didn't ask for the equation. So the only reason I'm using the equation is because it asked. But you could say, well, I can find this out without an equation, which would be great. But again, on the homework, it will ask for this type of equation. So I've zeroed out the 1995. I'm still going to drop this 15 cents per mile. And that equals this 40 minus 1995, which comes out to $20.05. Well, $20.05, that's how much money now Pam has to spend on mileage, right? We should be able to interpret this equation as we continue to solve it. Right, we've taken away the $19.95 from the $40 she started with or has, which leaves us with $20.05 to spend on mileage. So, if I want to know how many miles she can drive, we'll just divide 15 cents by 15 cents. But if I do it on one side, I got to do the other side. So just how many 15 cents are in $20.05? That's M. Now I do need the calculator. $20 and, whoops, $20.05 divided by 15 cents equals, and this comes up with the decimal, and it's okay that it is, 133.6 repeating, and the label for this would be miles. But the question on this one was, what is the maximum number of miles she can drive? Well, this would be for equality. However, this one is also saying that she's going to drive 133 miles and then a portion of a mile. Well, with what little experience I have with renting cars, they don't allow you to drive a portion of a mile without charging you the full mile. So in this case, they would charge her for 134 miles, which then becomes more than the $40. Which means that even though this rounded up would round up to 134, the actual answer ends up being 133 miles. She can drive a maximum of 133 miles and still be within her $40 budget. If, and again, I'm just saying, if it was 134 miles, let's say that it was 134 miles, well, I would put this into the calculator, right? $19.95 plus 0.15 times 134. And we see this is $40.05. I mean, it's only 5 cents more than the $40 she has, but we said that that was a maximum. So by changing this to 133, we can see that she's just barely under budget by 10 cents now. And that would be the maximum number of miles, the 133 miles.